Okay, 3.2, chapter 3.2, properties of a quadratic relation. Let me draw a quadratic and then I will label the different parts. So again, you have your what? Your axis of symmetry. So you have your axis of symmetry. And on your axis of symmetry, if it's opening up, the lowest point, if it's opening up, the lowest point is the vertex. Okay? And in this case, the vertex is a minimum. So this is your mean value. Okay, so that is your minimum value. Now, these 2 points right here, these 2 points are your what? Your x-intercepts, right? So those are your x-intercepts. That's when what? Y equals what? Y equals 0. So guess what they're called? Zeros. Yeah, so they're called zeros as well. Okay. So notice the zeros. The zeros have what in common? The y value is what? 0. So that means I can find the what? The axis of symmetry using the what? The zeros. Do you understand that? So I can use these two numbers right here to find the axis of symmetry because it's right between them. Is that okay? Okay, that's all I really had to talk about, and I failed to mention yesterday. Anyway, if I draw an upside down one, this is the vertex now here, and now this becomes a maximum value. Okay, and remember these are again your zeros. Okay, so these are your zeros as well. Okay? All right. Okay, so chapter 3.2, properties of quadratic relations. I'm just going to talk about today different parts of the parabola. So some key terms are like vertex, axis of symmetry, zeros, minimum value, maximum value. So we'll take a look at those key terms while we do the questions here. We're going to do, first of all, we're going to graph y equals x squared minus x minus 6 using a table of values. So what we're going to do is we're going to create a table of values right now, and then we're going to try to graph this. Okay. So let's make a table of values, and I hope you remember how to do that from grade 9. So let's go. So part 1, we're going to make a table of values. So I'm going to make a table. So there, oh, I should have maybe left more room here. But anyways, what goes here? X. What goes here? Y. Very good. Okay, what am I going to do for here? Yeah, you're going to choose values like 0, 1, 2, 3, 4, or whatever values you think you'll need. In this case, let me try these numbers and see if it works out. Again, you may need to, once you choose some of the values, you may need to choose a few more to get a better accurate graph, okay? So you may choose these originally, and then you think, oh, wait a minute, I need a couple more points to actually get an accurate graph. So then you can add more points later. But let's try these first. So what do I write here? Yeah, negative 2 squared. Is that okay? What's wrong with that? Yeah, you need brackets, right? Remember what I said. What happens is usually when I replace a variable with a number, I put brackets. So bracket, okay? So the value of x is negative 2, and that value of negative 2 is being what? Squared. So you got to go negative 2 squared with brackets. If you don't put the brackets, you will get the wrong answer. Okay, so let me continue here. So it's negative what? Negative. Again, you could put brackets here if you like. Well, I'll just put like this. Okay. Sure. Actually, let's put brackets. Minus what? 6. Okay. And that gives you something. Okay. So negative 2 squared is 4 plus 2, 6 minus 6 is 0. Is everyone okay with that? Shh. Okay, so negative 1 squared is 1, plus 1 is 2, minus 6 is negative 4. When x equals 0, you shouldn't really need to do any work. You should already know that the value is negative 6. Very good. Does everyone know that? Okay, remember this is your what? Part 2 actually. It says identify the y-intercept. This is for part 2. Okay, that's your y-intercept, right? Remember, for your y-intercept, x equals what? 0, and then it is your what? C value right there. That is your y-intercept. Yes, we talked about that yesterday. C, your last number there without an x, is gonna be your y-intercept. Okay, so the next one here is gonna be 1 squared minus 1 minus 6. So that's gonna give you what? 1 minus 1 is 0, minus 6 is negative 6. Okay, and then the next one is gonna be 2 squared minus 2 minus 6. 2 squared is 4, minus 2 is 2, negative 4. Okay. Now remember, if I want to graph a linear system, how many points do I need? 2, right? Because if I want to draw a straight line, I just need 2. However, for a quadratic, it curves. So you can't just do it with 2. You need at least a few to be able to see actually what the curve looks like. Okay? All right. So let's take a look. I'm going to start graphing this now. So let's start graphing what we got. What we're going to do now is going to plot negative 2, 0, negative 1, negative 4, 0, negative 6, 1, negative 6, 2, and negative 4. So let me plot that on the graph and see what it looks like. So we got negative 2, 0. So negative 2, negative 2 and 0 right there. Negative 1 and negative 4. 1, 2, 3, 4. Okay. 0 and negative 6. 1 and negative 6. And 2 and negative 4. Okay. So these are the points that we found when we made the table of values. All right, so the axis of symmetry is going to be between the middle of this one and this one. And if I look at these two numbers, is 0, negative 6, and 1, negative 6. Now, I could also find the axis of symmetry using these 2 points, and this is 2 and negative 4, or negative 1 and negative 4. Now, why is it that, okay, why is it that the axis of symmetry is in the middle of those 2 points? It's because they have the same what? Y values. So in order to find the axis of symmetry, you need 2 points with what? The same Y value. Okay? So write that down, please. Okay? To find the axis of symmetry, you need 2 points with the same Y values. Okay? Does that make sense to everyone? Why you have to have the same Y value? Because they have to be on the same level, right? and then in the middle of it is going to be your axis of symmetry. Now, let me draw it in here. So the axis of symmetry is somewhere around here. Okay. And in order to find the axis of symmetry, what you have to do is find the what? Middle. Yeah, the midpoint, right? Yeah, it's the midpoint. If you think about it, you're looking for the middle of those two. It means you're looking for the midpoint. So, yes, part of it though. The axis of symmetry. The axis of symmetry is just going to be x equals to something. Understand? So x equals to, again, you're going to get x1. What is the midpoint formula? x1 plus x2 divided by 2. Yes? So in this case, if I use, which one do you want to use? Let's use -1 and this one here. So I'm going to find the middle of -1 and 2. So that's going to give you -1 plus 2 divided by 2, and is equal to, okay, 0.5. Does that look like, is that 0.5? Yes. Okay, now. So some of you were doing the test, and a lot of you were like doing the wrong thing, okay? It was really simple if you knew that the line was what? Vertical. If the line is vertical, the equation of the line of a vertical line is what? X equals something, not y equals something. A lot of you put y equals 2 or something like that. It's not y equals 2, it's x equals, right? So the axis of symmetry, notice the axis of symmetry is a what? Vertical line. So the equation of it is what? X equals 0.5. Do you understand? Okay. So the next part, it says determine the vertex. The vertex is going to be the lowest. So the vertex is basically the lowest, right, or highest point of a parabola. So let me ask you this. In this parabola, is the vertex going to be a maximum point or a minimum point? It's going to be a minimum point. The vertex is going to be somewhere where? Right here. Okay, so the vertex is going to be somewhere around here. Do you understand? Because the parabola seems to be coming which way? This way here. Okay. And then goes down more. And then goes up. And then, you know, because it's symmetrical, I could put another point on this side as well, right? Yeah. But that looks kind of strange. There you go. Okay. So how do you find the vertex? Notice where the vertex is. The vertex is right on the what? Axis of symmetry. So that means that this point right here has a coordinate of what? What are the coordinates for that point right there? Yeah, I know it's 0.5 and something. Now, basically, what I need to do is find that something. So here, if we have the x value already, in order to find the y value, I just need to plug in the x value into the x, and then I will get my what? My y value, right? So it's basically like doing a table of values. All I need to do, okay, all I would be doing here is this, right? I'm looking for x equals what? 0.5, and I'm trying to find out what y equals, right? Same process. If you know the value of a variable, what do you do with it? Plug it in, okay? Say it again. If you know what? The value of the variable, you just what? Plug it in and work it out. Okay, it's that simple. So make sure you read the questions carefully. If you know the value of the variable, all you need to do is usually just plug it in and work it out. Yes?
So basically, you just plug it in the thing of the.
Yeah, all I do is here. I will do it here though. I'm not going to do it there. So y equals what? Um, 0.5 squared minus 0.5 minus um, 6, right? And so that gives you, I don't know, work it out. It gives you something like what? Negative 6.25. Okay, so notice that it actually goes down a little bit lower. So this is 0.5 and negative 6.25. So therefore, okay, the vertex is going to be 0.5 and negative 6.25. And in this case, my vertex is going to be a minimum. Okay, this is a minimum value. So the minimum value in this case is negative 6.25. All right, here, let's make a table of values quickly. X and Y, negative 2, negative 1, 0, 1, 2. Again, you may need different points, but let's try these first. Shh, shh, shh. Now, look, here it says negative. So you need that negative, and then again, I said X. When I see an X or a variable, I put brackets, and I replace the inside, I put the number. So negative 2 squared plus 3, I see an X, so I'm going to put brackets. I'm going to put the value of X in there, which is negative 2, okay, plus 4. And then what did you get? You got negative 6? Okay. And then the next one, what did you get? What did you get for the next one? 0, and the next one? 4, and then 6 and 6. Okay. Shh. Okay, quickly here. The y-intercept is what? Right there. That's my y-intercept, I know. Okay, that's because it's right there as well. So this is the y-intercept right here. Okay. Now let me graph it and see what this looks like. So that's not a very good graph to graph that. Shh. Okay, so it's negative 2 and negative 6, so somewhere in here. Okay, and then is what? Negative 1 and 0, somewhere in here. 0 and 4, somewhere on here. And then 1 and 6, somewhere in here. And then 2 and 6, somewhere here. So you notice that the curve will probably have to go this way. Now watch here. Some students are tempted to draw a straight line there. Well, it's not going to be a straight line, right? It should curve a little bit more. So please don't draw a straight line there. It should go up and then down again. The axis of symmetry is down the middle. Again, in order to find the axis of symmetry, you look for 2 points with the same y value. These two have the same y value. Okay? So there are your 2x values, 1 and 2, with the same y value of 6. So it's going to be x equals 1 plus 2 divided by 2, which is 1.5. That's x equals 1.5. Remember that. Okay, so for my vertex, I know the value of x, which is 1.5. I just need to find the y value, so y equals to negative 1.5 squared, okay, plus 3 times 1.5 plus 4. And that gives you 6.25, I believe. Okay, so therefore your vertex is where? Is 1.5 and 6.25. Now, is the vertex a maximum or a minimum? It is going to be a maximum in this case. Okay, so this is the vertex. No, you don't. But but you should know what it means to be a max or a min. So let me do this example, but I'm going to use Decimus here. So a model rocket is shot into the air from a roof of a building. Its height, h above the ground, measured in meters, can be modeled by the equation h equals blah, 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 where t is time elapsed since liftoff in seconds. Determine the greatest height reached by the rocket. Now, I am going to use Decimus to graph this, and I will show you how to find all of these values. However, I do want to kind of get you to think about what this graph should look like somewhat. Okay, on this axis, what am I going to put? On this axis, on the horizontal axis, what is it going to be? It's going to be time, right? On the vertical axis is going to be the what? The height. Now, notice what it says here. The rocket is not shot from the ground, so the height at time 0 is not where? Is not at the ground. But how high is it? How high is it? Very good. 5. So that's 5. Okay? So the height, okay? The height of the building is actually what? 5. Okay? It's right there. Okay? When t equals 0, okay, what is the height of, do you understand? So when t equals 0, the height is already 5. Now, does this parabola open up or down? Okay, down. So I know that the parabola or the rocket is going to go where? Up like this and down. Do you understand that? Okay, so that's just a quick sketch to give me an idea of what this might look like. Is that good? Okay, now let's do it in Decimus, and you'll see how easy it actually is to find all of these values. So here we go. Okay. Okay. So the first thing is that find the highest point it reaches. Now, what do you call that highest point? The vertex. And the vertex is somewhere here. So all I do is take my mouse and then try to click somewhere up here. Oh, there you go. You see, when I clicked here, you see it showed a gray dot there. That's the maximum point in this case. So the maximum point occurs at 3.5, 66.25. So let's go back to my here. And so what's the answer? Determine the greatest height reached by the rocket. What was it? 66.25. Okay. Shh. Okay, there you go. 66.25. Remember, the first number is your what? Time. The second number is your what? Your height. Okay. All right, let's take a look. How long is the rocket in flight? Okay, so how long is the rocket in the air? In the air, 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 still in the air, 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 hit the ground. So right there, which is what? 7 something, right? Yeah, there you go. 7.14 is how long the rocket has been in the air. From 0 to 7.14. Remember, I don't care about what? The negative side. So I'm going from 0 to 7.14. Does everyone understand? Okay. So here, the answer to this one is 7.14 seconds. And this was, I think, in meters. Determine the height of the building. Well, you should know already. We talked about it. How high is the building? 5. Because that's where it was shot from. Does everyone understand? So it's 5 meters right there. Okay. When is the height of the rocket 61.25? Now, I told you, when you know the value of the variable, all you need to do is what? Sub it in. What value is that for? H. So this is H equals 61.25. So all I need to do is plug this into Decimus as what? What would I write here? Well, what is? Y is equal to 61.25. Okay. Notice what it does. There is 61.25 meters high. And notice here, that's kind of a tricky question because it says, look, there are actually what? Two different times it hits 61.25. Does that make sense? Because the rock is going up and then hits 61.25. When coming down, it hits 61.25 again. Does that make sense? So in this case, you do need to write both of the answers to get the full mark. Okay. So when is the height of the rocket? 61.25 meters. It was time is equal to what? 4 and was oh, sorry, I didn't see that. 2.5 and 4.5. Okay. So 4.5 and t is what? 2.5. Okay, so at those two times, it hits 61.25. Is that okay? All right. So that's what you have to do if there's a question like that in the homework. You should use Desmus for now. However, sooner or later, you will learn how to do it algebraically by the end of chapter 6. Okay?